Well, as exciting as torque was, there is one other application of cross product that comes easily to hand. I mean, there are lots of applications, but this is one of them that's quick and easy, and that's a geometric application. So when you take a look at the geometry involved in the formula for the magnitude of the cross product, you can see u cross v is equal to the magnitude of u times the magnitude of v times the sine of theta. That's equal to the area of the parallelogram formed by u and v. Let me show you what I mean down below. So we have a parallelogram formed by u and v. Let me grab a ruler real quickly to draw this. All right, so I have my lovely ruler right here. So I'm going to try to draw as best I can a parallel vector to v over that comes from the tail of u right here. So I'm trying to go tip to tail here. So I'm going to try to draw up this way, right? And then draw this way. I probably should have done that one first, but that's all right. Okay, so there's another u vector, of course, because vectors are free. So this is u also, and this is v also. So you have one going this way, hello v, and then another one there, that's u. All right, so let me highlight those real quickly. This is u, and so is this. And this is v, and so is this, because vectors are free. Well, they form a parallelogram, and they have an angle between them over here, which is theta. Okay, so if I was going to drop a projection of v onto u like that, that would get us our height, h, right? Because there's a little right triangle in here. So the height of that parallelogram, which is what we learned how to call it in geometry class eons ago. All right, so when we think about this, the sine of theta is equal to the height, the opposite, over the hypotenuse. Well, the hypotenuse is the magnitude of the v vector, right? So let me write that up. So the sine of theta is equal to the hypotenuse, or excuse me, the opposite, which is the height of the parallelogram, divided by the magnitude of v. Which means that the height of my parallelogram is equal to the sine of theta times v, or the magnitude of v, I should say. Why does that matter? Well, because remember, the area of a parallelogram is base times height. So let me remind everybody. Recall, area of a parallelogram, of which a rectangle is the most common, well, actually square. A square is an even more common one, right? So squares and rectangles are just modified versions of these, where all the angles are right angles. So theta is equal to a right angle, is equal to base times height, right? The length of the base times the height. But the length of the base is the magnitude of u. And the height we just discovered is v times the sine of theta. And if you're thinking that looks familiar, yes it does, because that is the definition of the cross product. Well, the magnitude of the cross product, I should say. So this is equal to, by definition, the magnitude of u cross product with v. Interesting. So that means for us that the area of a parallelogram formed by two vectors, which is one of the reasons that we talked about the parallelogram method of drawing two vectors, determined by u and v, is u crossed with v, the magnitude, which is u, the magnitude of u, times the magnitude of v, times the sine of theta. That is the entire area of this parallelogram. But wait, there's more. Because not only is there a parallelogram there, but there's a triangle there. So if I take the two vectors, u and v, they also form a triangle. If you take a cross bar from the tip of the v vector to the tip of the u vector, there's a triangle in there. And we could find the area of that triangle because the area of the triangle must be half of the area of that parallelogram. So the area also, the area of the triangle formed or determined by u and v is half u cross v. In other words, it's half u, magnitude of u, magnitude of v, sine of theta. That orange triangle right there is this formula right here. It's the same one as for the parallelogram, but it's cut in half because the triangle is forming half of that parallelogram. All right, so now we can go use those formulas to answer some questions. All right, so we want to find the area of the triangle with vertices at the three given points, or explain why it is impossible to do so. Okay, so let's start with the first one. So I need to form some vectors. So I need P, Q, and PR. So I need to have this go from, let's let vector U, oh, what color did I pick? Sorry, just to keep my color coordination alike. So I'm going to go vector U, which is P to Q, which would be terminal minus initial. So 3 take away 1 is 2, 7 take away 3 is 4, 5 take away a negative 1 is 6. And then V, vector V, would be from P to R. They have to have the same origin point. They have to have the same starting point to make the parallelogram work. So if you have to have a point P over here in the corner. So that's what I'm doing. So this would be, let's see, terminal minus initial. So 4 take away 1 is 3. 8 take away 3 is 5. 6 take away negative 1 is 7. Okay, so the area of the triangle that these two vectors form would be equal to I, J, K. It's U crossed with V, so 2, 4, 6, 3, 5, 7. And then the easy thing to do is throw on the other I and J. 2, 4, 3, 5. And then I'm going to have half of this, right? Because it all has to be multiplied by a half in order to make it work, right? Because the area of the full cross product, the full cross product will get you the area of the parallelogram. Half of that cross product will get you the area of the triangle. All right, so let's see here. This is a half times, and then I'm going to go down the diagonal, down the diagonal, down the diagonal. So 28I, 18J, 10K, minus, and then I'm going to go up this diagonal. So 12K, 30I, and 14J. All right, well, and it's really a half times the magnitude of all this. I shouldn't put brackets around it. What I really want is like vertical bars because I want to find the magnitude of all of this. I want to find the magnitude of the cross product and then multiply that magnitude by a half. Oops, sorry, I keep having problems over there. Right there. because my formula says I want to take the magnitude of u cross v. So I'm finding u cross v, but then I need to take the magnitude of it and multiply it by half. I'm actually doing the triangle one down here. So I'm finding u cross v right here, right? This is u cross v, u cross v right in here, but I still need to find the magnitude of it. That's why I'm leaving vertical bars over it. So this is 1/2 magnitude of, now what am I going to have left when I do this? It'll be 28 take away 2, which is negative 2i, 18 minus 12, right? 18 minus 14, there it is. 18 minus 14, which is 4j, 10 take away 12, which is negative 2k. So I'm finding the magnitude of that. So that'd be 1/2 square root 2 squared plus 4 squared plus 2 squared. Because of course we don't care about the negatives because we're going to square them to make them all positive. And that's 1/2 square root of 24. 24 is 4 times 6, so that would be 1/2 times 2 square root of 6, which is just the square root of 6. So the area of the triangle would be square root of 6 centimeters squared. If I assumed, I meant to put this up here, assume centimeters as our unit. So if we had centimeters as our unit, then this would be centimeters squared. So for example, if this was 1 centimeter, 3 centimeters, negative 1. And there we go. All right, what about the next one? Okay, well, U would be PQ, which would be, let's see, 5 take away 3 is 2, 4 take away 2 is 2, 7 take away 1 is 6, and V, which is PR, is 9 take away 3 is 6, 8 take away 2 is 6, 19 take away 1 is 18. Uh-oh, we have a problem. So there's a problem with this because these two vectors are parallel. So we need to make a note. So note, this is not forming a parallelogram. They're actually the same vectors. So if I was going to put them on the coordinate axes, U goes like this, over to up 6. Well, it'll be hard to draw in 3 dimensions, but you'll get the idea. So U goes out 2, over 2, up 6. So U goes like this way, and V goes the same way. They're parallel. So it's in 3 dimensions. So V is equal to 3 times U. So that means that U is parallel to V. And therefore, there is no triangle formed because they're parallel vectors.